Welcome to the Explainer. When we look up at the night sky, it's super easy to feel a sense of peace, just seeing all those quiet, twinkling lights. But as we're about to see, the reality of space is far from peaceful. It is a hostile, chaotic, and unimaginably dangerous place. Today, we're taking a chilling but absolutely fascinating journey into the cosmic horror catalog. Think of this as a sort of campfire science session, where the monsters are real and they are out there right now in the dark. We aren't just going to look at them, we're going to break down the terrifying physics of exactly how they operate.
The universe is 13.8 billion years old, vast, ancient, and mostly invisible. And somewhere out there are answers to questions that keep scientists awake at night. Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen it before.
To wrap our heads around these cosmic horrors, we've broken everything down into 5 main themes: dead stars and gravity traps, invisible forces and warped time, cosmic missiles and rogue worlds, deep voids and alien artifacts, and finally, the threat from our sun.
So let's jump right in. To start, we have to ask a terrifying question. What actually happens when the very force that keeps us grounded, gravity, turns into an invisible predator?
Which brings us to Section 1, Dead Stars and Gravity Traps. This is what happens when giant stars collapse.
We're talking about the unimaginably dense leftovers of massive stars that died and left behind absolute gravitational nightmares. On the left here we have black holes. These are born when giant stars run out of fuel and literally collapse inward under their own staggering weight, creating a singularity. That's a point of infinite density. Imagine cramming Mount Everest into a space the size of a pinhead. The gravity is so powerful that not even light can escape, making them essentially invisible cosmic ninjas. But on the right, we have neutron stars. Sometimes dying stars don't quite become black holes, they become these. A neutron star packs an entire sun's worth of mass into a sphere about the size of Manhattan. Just a single teaspoon of this material would weigh 1 billion tons.
So what happens if you get too close to a black hole? Well, you experience this highly technical, albeit ridiculous-sounding term, spaghettification. The black hole's gravity pulls so much harder on your feet than your head that you just get stretched out like cosmic taffy. But here's the truly wild part. Black holes aren't just cosmic vacuum cleaners. When they gorge on too much matter, the intense magnetic fields at their edges can actually supercharge that material and vomit it back out, blasting jets of radiation so bright they completely outshine entire galaxies.
And neutron stars? They've got their own brand of terror, specifically a rare type called magnetars. Their magnetic fields are trillions of times stronger than Earth's. If you somehow got within 1,000 kilometers of a magnetar, the magnetic forces would literally rip the electrons right out of your atoms. You would completely disintegrate before you even touched the surface. Plus, they spin hundreds of times per second, firing out these deadly radiation beams like massive cosmic lighthouses. They are basically cosmic grenades just waiting to go off.
Moving on to Section 2, Invisible Forces and Warped Time, the Unseen Universe. Because as scary as black holes and magnetars are, the absolute most terrifying things in space are the ones we cannot see coming. Check out this number, 95%. That is the staggering chunk of our universe that is completely 100% invisible to us.
Right, so look at that tiny 5% slice. That is normal matter. That's everything we can see, touch, interact with, and actually understand. The massive 95%, that is dark matter and dark energy. Dark matter basically acts as this invisible gravitational skeleton holding galaxies together. Without it, the rotation of galaxies would fling stars apart like confetti. Then there's dark energy. It's this mysterious force stepping on the gas pedal of universal expansion. It is making the universe expand faster and faster, pushing galaxies further away from each other. Eventually, it could lead to a big rip, where the expansion gets so incredibly violent that everything, right down to the atomic level, gets pulled apart into nothingness.
This quote from our source material sums the whole situation up perfectly. We are entirely surrounded by a mysterious substance that dictates reality, and we're basically ants trying to guess how electricity works. I mean, it's the ultimate cosmic horror, right? Realizing just how little we actually understand about the forces controlling our survival.
And speaking of things we can't see coming, let's talk about gamma ray bursts. If a black hole is a slow burn, this is a total jump scare. When a giant star collapses or two neutron stars smash into each other, they fire these highly directional jets of deadly radiation straight out from their magnetic poles. Because the energy is focused into tight beams instead of spreading out, they act just like cosmic sniper rifles. A single burst releases more energy in a few seconds than our sun will in its entire 10 billion-year life. If one happened to be aimed at Earth, our ozone layer would vaporize instantly. 1 second you're sipping coffee, the next humanity is deleted. No warning at all.
Oh, and if the physical threats weren't enough, time itself is out to get us. Thanks to Einstein's relativity, we know time bends and stretches depending on gravity and speed. Near a black hole's event horizon, time slows down drastically. You could hover there for just a few hours, and that could equal millions of years passing back on Earth. You take a quick space trip, come back, and find human civilization is completely gone and cockroaches are running the planet. Time isn't stable. It is an absolute relativity nightmare.
All right, Section 3, Cosmic Missiles and Rogue Worlds, Wandering Threats. Here we shift from invisible forces to massive, kinetic killers hurtling through the dark. Let's compare these wandering threats. On one side, we have our local hazards, asteroids and comets. But on the other side, we have rogue planets. These are worlds that were violently gravitationally kicked out of their home solar systems during their chaotic formation years. Now they just drift alone in the eternal dark, completely starless and frozen. Astronomers estimate there could be billions of these invisible, Earth-sized planets wandering our galaxy. And the horror movie twist? Some of them could actually harbor life. Subsurface volcanic activity could keep subterranean oceans liquid, meaning pitch-black alien ecosystems might be evolving right now, having never even known the warmth of a star.
But let's bring it back to those comets for a second. 70,000 kilometers per hour. That is the speed of a giant icy comet acting as a deep space bullet. We don't even need exotic rogue planets to end us. Remember, 66 million years ago, a 10-kilometer-wide asteroid deleted the dinosaurs in a single afternoon. And we are still highly vulnerable. In 2019, a 100-meter-wide city-killer asteroid zipped right past Earth, and we didn't even spot it until 2 days after it passed us. Our reset button is still out there, circling patiently.
This leads us to Section 4, Deep Voids and Alien Artifacts, the Psychological Horror of Space.
This is where the emptiness of space itself becomes a real psychological horror. Imagine looking up at the night sky and seeing absolutely nothing. No stars, no galaxies. That is the Boots Void. It's an enormous region of space, 330 million light-years across, with almost nothing in it. They call it the Great Nothing. It is so massive that if Earth were dropped right into the center of it, we wouldn't have even known other galaxies existed until modern telescopes were invented. It's like a giant glitch or a scar in the cosmos, and astrophysicists still struggle to explain how a region of absolute nothingness this vast could have formed over the lifespan of the universe.
Then we have the anomalies we actually can see. Take a look at this comparison with Tabby star. Normal planetary transits like Jupiter passing in front of our sun only block about 1% of the light, but Tabby star was dimming by up to 22%. Something absolutely enormous was blocking it. Now, while it might just be a massive, irregular swarm of dust, it sparked all these massive theories about an alien Dyson sphere. That would be a technological megastructure wrapping the star to harvest its energy. Even if it's abandoned, just the idea of half-finished cosmic architecture drifting out there is haunting. It implies a civilization in a completely different league than us, one that perhaps already met its own cosmic end.
Finally, Section 5, the threat from our sun, Earth's reset button.
Because, let's be honest, we don't need to look into deep space to find something that can end us. Our own life-giving sun is a volatile nuclear reactor. Just look at this historical timeline. In 1859, a massive solar flare called the Carrington event slammed into Earth. It literally sparked telegraph lines and electrocuted operators. Fast forward to today, if that exact same solar flare hit us right now, the electromagnetic pulse would cripple the global internet, shut down power grids, and cause trillions in damage. Society would hit the reset button just because the sun sneezed. And looking to the future, as we attempt deep space travel, astronauts will face cosmic radiation storms that punch right through spacecraft shielding, shredding their DNA. The only reason we aren't being microwaved alive right now is Earth's magnetic field acting as a giant cosmic umbrella. Which brings us to our final thought. We've explored invisible predators, time-warping traps, rogue planets, and our own highly volatile star. So the real question is, if the universe is this much of a cosmic minefield, are we actually safe? Or have we just been incredibly lucky so far? Think about that the next time you look up at a seemingly peaceful night sky. Thanks for joining me on this explainer, and keep your eyes on the stars.
The universe doesn't care about us. It never did. But we care about it. And that is what makes us extraordinary. If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then, stay curious and keep looking up.